Hello everyone, welcome to chemistry classes. Okay, so in the previous session we have discussed about the relation between an equilibrium constant and Nernst equation, and now we are going to derive or establish another relationship of Nernst equation with so Nernst equation electrochemical E cell potential of the cell with Gibbs energy. Now we are going to derive a relationship, or we are going to establish a relationship between electrochemical cell and Gibbs energy of the reaction. So what do you mean by electrochemical cell? Electrochemical cell. So in the basics of on starting of electrochemistry, we have discussed about electrochemical cell. So in the whole lecture we are discussing about electrochemical cell only. So what is the definition of electrochemical cell? Electrochemical cell is a device which converts chemical energy of a chemical reaction, chemical energy of a spontaneous chemical reaction into electrical energy. So that is called as electrochemical cell. So the electrochemical cell converts chemical energy into electrical energy. So where does that chemical energy comes from? So that chemical energy of a chemical reaction is none other than, that is, Gibbs free energy of a chemical reaction. So here for every chemical reaction, especially for spontaneous chemical reactions, there is Gibbs free energy. For every chemical reaction that exists, Gibbs free energy. So we must understand what is Gibbs free energy. So otherwise we cannot calculate Gibbs free energy. So here simply I explain what is Gibbs free energy. What is the formula to calculate Gibbs free energy? You might be remember that delta G is equals to delta H minus T into delta S. So this is my equation to calculate Gibbs free energy. So here delta G is Gibbs free energy, where delta H is the enthalpy of the system. Enthalpy is nothing but total heat content of the system. The total heat content is nothing but total energy of the system, where delta H is total energy of the system. In that total energy, this much amount is reduced or less or subtracted. T into delta S, this much amount of energy is subtracted. That remaining energy is called as Gibbs free energy. So this much term T into delta S, so this much energy is retained in the system. T into delta S is nothing but this is the amount of energy that is retained by the system. So Gibbs free energy is nothing but the amount of energy given out by the system for the useful work. The energy given out from the system to perform useful work means it is nothing but energy given by the system. So the total energy of the system is delta H. System does not give all of its energy, so system always retains some amount of energy with it, and it gives out some amount of energy. So that some amount of energy given out by the system is called as delta G. To understand this, I'll give a simple example. So now the corona pandemic is going on. If I have got 100 crore rupees, so actually I don't have that much. So for example, I have 100 crore rupees with me and I want to donate some amount. I cannot donate all of my 100 crores to government. Why? If I donate all of my 100 crores, I should come to the road. So that's why I will donate some amount of energy. I should retain some amount with me for my life saving or for my life. So I will retain, for example, so this is 100 crores. If it is 100 crore, I will retain 50 crore with me. I retain 50 crore with me, and I will donate how much crore? 100 minus 50. I will donate only 50 crores. So remaining 50 crores is donated. Delta G is equals to 100 minus 50. So 50 crore rupees is donated to the government. Means what? Delta G is equals to 50. This much amount of energy cannot be given out. This much amount of energy is used by the system. It is retained by the system. So the remaining amount of energy is called as delta G, Gibbs free energy. That free energy can be converted into other forms like electrical energy. So in my galvanic cell, the Gibbs free energy given out by the system is converted into electrical energy. So that by using that electrical energy, we can run electrical gadgets, motors, fans, lights, etc. So I hope all of you understood about exact meaning of Gibbs free energy. So now come to the point. What's our point? Electrochemical cell means nothing but cell potential. We are going to derive a relationship between cell potential and Gibbs energy. Cell potential and Gibbs energy. So now in an electrochemical cell, electrical energy is converted into chemical energy into chemical energy is converted into electrical energy. Chemical energy means what? Gibbs free energy. Gibbs free energy of the cell is converted into electrical energy. We measure electrical energy in terms of cell potential. So it indicates that there must be a relationship between cell potential of the cell and Gibbs energy. As Gibbs energy varies, there must be, we can find the variation in cell potential also. So now what is the exact relationship between cell potential or electrochemical cell and Gibbs energy? Now we are going to derive that or establish that. So here in an electrochemical cell, system does work. System means my electrochemical cell. System does work by transferring electrical energy through the circuit. So electrochemical cell, what it does? Electrochemical cell converts chemical energy into electrical energy. Means our electrochemical cell, this is my system. Electrochemical cell is my system. The system does work. The system does work by transferring its electrons. Transferring its electrons is nothing but transferring electrical energy through the circuit. So this electrochemical cell gives energy in the form of electrical energy to the circuit. Means work is done by transferring electrical energy through the circuit. Now, and we know that electrical work done in 1 second. Electrical work done in 1 second is equals to how much? Electrical work done is equals to electrical potential of the system. Electrical potential is nothing but cell potential. Electrical potential of the system multiplied by total amount of charges passed. Here the electrical work done is equals to electrical work done in 1 second is equals to electrical potential multiplied by total charges passed. So in our electrochemical cell, if electrical work is done, that electrical work is equal to cell potential. That is equal to electric potential is nothing but cell potential of the system, that is multiplied by the total amount of charges passed through the cell. Here delta G of the reaction is, what is delta G? It is nothing but it is the measure of maximum amount of useful work that can be obtained from a chemical reaction. Now only we have discussed about that. So Gibbs free energy is nothing but total amount of that is it is a measure of maximum useful work that can be obtained from a chemical reaction. Means the maximum amount of energy that can be given out. So now based on this we can write delta G is equals to maximum work done. Maximum work done is equals to maximum work. We will give W max is nothing but maximum work. We will consider this as equation number 1. Equation number 1. In a reaction occurring in electrochemical cell, in our electrochemical cell, if a chemical reaction occurs, the potential of that electrochemical cell is E cell. The potential of that electrochemical cell is to be taken as E cell. Now work is done. When the work is done when NF amount of, the amount of charges means NF amount of charges passed through the cell. NF amount of charges passed through the cell of the potential E cell. See here, according to this, electrical work done, maximum amount of electrical work done is equals to amount of charges multiplied with electrical potential. So here electrical work done in 1 second is equal to the electrical potential E cell multiplied by total charges. Total charge is N into F. F means Faraday. N is total number of electrons. So this much amount of charges passed through the cell having potential E cell. So maximum work is equals to NF E cell. But in a galvanic cell, in our galvanic cell, what happens? Charge has to be passed reversibly. In our galvanic cell, the electric charge has to be passed reversibly. Here in our galvanic cell, work is done by the system on surrounding. Our system is doing work, means work is done by the system on surrounding. For that condition, what we have to take? W is equals to negative according to thermodynamics. So work done is equals to negative. Therefore, this equation becomes W max, maximum work done, is equals to minus NF E naught cell, NF E cell. So I will call this as equation number 2. That is my equation number 2. From equation 1 and 2, from equation 1, delta G is equals to maximum work, equation 1, and equation 2 is maximum work is equals to minus NF E cell. So now we can equate equation 1 with equation 2. Here W max is equal to delta G. Here W max is equals to minus NF E cell. So directly we can write delta G is equals to minus NF E cell. Delta G is equals to minus NF E cell. So this is the relationship between Gibbs free energy of the reaction and cell potential or electrochemical cell. These terms explains electrochemical cell. And if this reaction is calculated in standard conditions, standard condition becomes what? Delta G becomes delta G naught and E cell becomes E naught cell, because N and F are constants. N is number of electron transferred and F is our Faraday constant. So now delta G naught is equals to minus NF E naught cell, minus NF E naught cell. So this is the very much important relation. So by using this relation, we can calculate Gibbs free energy of the reaction by using this here. If we know the cell potential value, just by knowing cell potential value, we can calculate the important thermodynamic quantity, that is none other than delta G naught. So here delta G naught of the reaction, it is difficult to calculate by our normal method. So that can be easily calculated by using this method. And one more conclusion can be drawn from this, that is feasibility of the reaction. Feasibility means what? Whether the chemical reaction takes place or not, that is called as feasibility. By using this equation, we can calculate, we can guess or we can determine feasibility of the reaction. See here, for a chemical reaction to be spontaneous, what is our condition? For a spontaneous chemical reaction, delta G must be equal to negative. It must be less than 0, means it must be negative. So here for a spontaneous chemical reaction, delta G is equals to negative. This term becomes negative only when this is positive, because N is positive, F is positive. This term remain as negative when E naught cell is positive. If E naught cell becomes negative, what happens? Negative into negative, it becomes positive. So positive, delta G positive means what? The reaction is non-spontaneous. So by this we can calculate, or by this we can understand whether our chemical reaction is feasible or not. The feasible means what? All spontaneous chemical reactions are feasible. For a spontaneous reaction, delta G is equals to negative. For delta G naught to be negative, our E naught cell must be positive, and we know what is the meaning of positive E naught cell and negative E naught cell in my previous lecture. If you don't watch that, go through my description and you will get a link of playlist of electrochemistry. Then you can watch there. It is, I think, part 10. Okay. So now we understood that by this equation we also know that we can also understand, or we can also calculate that feasibility of the chemical reaction. For a chemical reaction to be feasible, delta G must be negative. For delta G naught must be negative, our E naught cell must be positive. If E naught cell becomes negative, the reaction is non-spontaneous. Okay. And now, and one more important thing, from the standard Gibbs energy, by using this equation we can calculate standard Gibbs energy. By using standard Gibbs energy, we can also calculate equilibrium constants. Here once again we can calculate equilibrium constant by using this equation. Equilibrium constant can also be calculated by the equation delta Z naught is equals to minus RT ln Kc, and I'll show how this equation is derived. So to calculate equilibrium constant, what is my Nernst equation? My Nernst equation is E naught cell is equals to 2.303 RT divided by, sorry, not 2.303, we will consider natural log only, we will consider ln, because here they have given in terms of ln. E naught cell is equals to RT divided by NF ln Kc. So this is our Nernst equation to calculate equilibrium constant. So these two terms comes this side. NF E naught cell is equals to, what happens? RT ln Kc. Here in the place of NF E naught cell, we can substitute RT ln Kc. So we can also calculate equilibrium constant by knowing delta Z naught, Gibbs free energy. So this Gibbs free energy is calculated by using E naught cell of the reaction. So this gives the relationship between electrochemical cell and the Gibbs free energy of the reaction. And also we know that, and please remember these two are very important here. E naught cell is an intensive property. E naught cell is intensive parameter, or it is called as intensive property. E naught cell is intensive property. I think you must be remembered that what is intensive property and what is extensive property in thermodynamics. So intensive property, it is the property of the system which is independent of amount of matter present in the system. It is independent of amount of matter, the quantity of matter present in the system. So E naught cell remains constant for any quantity of the reaction, chemical reactant, but delta Z naught or delta G is an extensive property. It is an extensive thermodynamical quantity. Which one? Delta G naught is extensive property or extensive parameter. So this delta G naught is extensive. Extensive means what? The property of the system which is dependent on the amount of substance present in the system. Here amount of substance, we are not changing any amount, but here what we are changing? We are changing the value of n, the number of electron transferred. Means delta G depends upon number of electrons. Delta G is an extensive property and it depends upon number of electrons transferred in the system. So for this, I will better understood this by taking an example. So let us take the example and write delta Z naught value. Example for Daniel cell. What is the chemical reaction taking place in Daniel cell? Here Zn plus Cu2 plus gives Zn2 plus Cu. So this is the chemical reaction taking place in the Daniel cell. Now let us write this value. Which value? This value for this chemical reaction. So delta G is equals to minus n is equals to how much? For this reaction n is equals to 2. Delta G is equals to minus 2 Fe cell. For this reaction, delta G is equals to minus 2 into Fe cell, where minus 2 is this 2 is nothing but N. In the very same reaction, I'll write in this form. Here only the stoichiometric coefficients are changed to Zn2 plus Cu. Here the total number of electron transferred is equals to how much? Here 2 Cu are there. 1 Cu gets 2 electron and it is reduced, and 2 copper atoms are here, and for 2 copper atoms the 4 electrons are required to reduce, and for 2 Zn it loses 4 electrons, so N is equals to 4. Now delta G is equals to minus 4 F cell. So from this you can clearly understand that the value of delta G depends upon N, isn't it? So delta G is an extensive property, but E cell is an intensive property. So I hope all of you understood this, and let us solve a problem on this. And we will solve a problem on this, and then we will go forward. And I will remove this also. The E0 cell of Daniel cell is here. I am going to solve a problem. The E0 cell of Daniel cell is the E0 cell of Daniel cell is 1.1 volt. 1.1 volt. Calculate the standard Gibbs energy of the reaction. They have given chemical reaction, that is Zn plus Cu2 plus gives Zn2 plus Cu. Here now we have to calculate E0 cell, we have to calculate standard Gibbs energy for this reaction. So now we will calculate the standard Gibbs energy of this reaction. So what is the formula to calculate standard Gibbs energy? Delta G0 is equals to minus NF E0 cell. So my solution. What is given here? What they have given? They have given E0 cell. E0 cell is equals to 1.1 volt. Then what they have given? What we require? N is equals to, this is Daniel cell, N is equals to 2. What is F? F is equals to 96,500, or we can take 487 coulombs per mole. Now all the data are given, so directly we can calculate. Delta G0 is equals to minus N means 2 into F means 96,487 coulombs per mole, and have a practice to write unit with the quantities. And E0 cell is equals to 1.1 volt. Now let's multiply these. 2 into 96,487 into 1.1, it is found to be 2127. What's remain here? Coulombs volt per mole. So minus 21227 coulombs volt per mole. So now delta G naught is equals to, I'll write minus 212.27 kilo coulombs volt per mole. And we know that what is coulomb volt is equals to joule. Coulomb volt is equals to joule. See here, what is the exact meaning of this? See here, the amount of energy required to transfer 1 coulomb of charge across the cell potential of 1 volt. Cell potential of 1 volt. The amount of energy required to transfer or to cross or to transfer 1 coulomb of charge across the cell potential of 1 volt. So coulombs volt is equals to joules, means 1 coulomb volt is equals to 1 joule. So directly I can write delta G naught is equals to minus 212.27 kilojoules per mole. So this is my answer, kilojoules per mole, isn't it? Okay, so now I think all of you understood this, and thank you so much for watching. If you find this video is useful, please like, comment and share among your friends. Thank you so much for watching.